Alright guys, in this video we're going to be solving October number 24 P41 question number 2. We've solved question number 1, it's been uploaded, you can check it out. And in this video we're going to be dealing with object-oriented programming. So let's get started. A computer program is designed to simulate horses doing show jumping. In show jumping, horses jump over obstacles called fences. A horse successfully jumps a fence if it does not knock the fence down. Alright, so we're going to be dealing with the horses, I guess. And the program is written using object-oriented programming. The class horse stores data about the horses. So what we have here is a class diagram, and we have the attributes and methods defined to us over here. And part A, part 1 tells us that to declare the class horse and its constructor. Do not declare the other methods, and if you're writing in Python, add comments. Alright, so let's do this. Let's declare the class horse. So this is how you declare a class in Python, and for its constructor, the constructor initializes name, max fence height, and percentage success to its parameter values. So the way we define a constructor is using the init function, and since we're going to be having some parameter values over here, I'm going to be naming this as p name, p max fence height. You can name your parameters anything you want. There's no restriction over here besides the restriction on the attribute names. So p percentage. Alright, now I'm going to be assigning these parameter values to the attributes that I'm going to be declaring over here. So it's going to go like this: self dot underscore underscore. This means that the attribute is private, and name. Alright, so this is going to be assigned the value p name, and we're going to be declaring the data type in string in comments. Now for the next, it's gonna be max fence height, and this is gonna be p max fence height, and this is integer. By the way, these declarations of the data types is already given over here. I'm just copy pasting that. Alright, now for the third variable, it's percentage success. This is going to be assigned p percentage, and this is an integer. Alright, so these names over here, these are the attributes, and these are the parameter values. So it doesn't matter what you name your parameter values, your attribute names must be the same as it's defined by the examiner. Alright, so this was the constructor. So this was the constructor. It didn't tell us to make anything else. So moving on to part 2, the getters get name and get max fence height each return the relevant attribute for 3 marks. Alright, so we're going to be defining get name, and once again self. And basically what self does is it represents the instance of a class that you're creating. So this is a class right now, and further on in the question we're going to be creating an object of this class. So what the self does is it binds the object and class, so it allows the object to access whatever there is in the class. So I know this is not the perfect definition, but I hope you get my point. Alright, so this is going to be just returning self dot underscore name, and def get max fence height is gonna be returning max fence height. Right, oh wait, self, I forgot to add the self. Alright, pretty self-explanatory. So these were the getters. Part 2 is done. Now we're going to be moving on to part B. So the array horses stores object of type horse, meaning the class horse. The program has two horses. The horse named, alright, this the other horse. Write program to declare the array horses local to the main program. Okay, so this is not in the class. This is going to be in the main program with space for two horse objects. Alright, store the two horses described in the array. Output the name of both horse objects from the array, and we're getting 5 marks for this. So clearly this is not going to be a simple task as easily as it's mentioned over here. The thing is that the examiner is trying to get you to use what you've made over here. Alright, now we need to keep in mind everything that we've defined in the class. So for that, let's move on to the first point first. Declare the array horses local to the main program with space for two horse objects. So usually if the examiner didn't mention that we had specifically two horse objects, then we would just declare an empty list, but in this case we have to define everything. So it's gonna go like this: horse, and we're going to be matching the parameter values that we defined in the constructor. So first the name comes, and I'm just going to be declaring a null value for this. Then we get max fence height, it's going to be -1, and p percentage is also an integer, so it's also going to be -1. So these are the null values that I've already initialized the array with, and this is just going to be multiplied by 2. Alright, yeah. Now the first horse is named Beauty, so we're going to be accessing the first index, which is the 0 index, and it's going to be storing we're first going to be going with Beauty, then 150, then 72. Alright, then horse 1 is gonna be horse 1 is gonna store the name Jet. It's gonna have a height of 160 and then 65% percentage success. So these were the two horses, and let's run to see if it works. Doesn't work. Alright, so why doesn't it work? So let's try this. Oh, my bad. The reason why it wasn't working because I was missing the S over here. So it was as if I was accessing a class, which is not possible, by an index. Alright, so yeah, that was a problem, and yeah, it works till now. Pretty good. Now we're going to be moving on to the second point: store the two horses describing the array. Alright, that's stored. Moving on to the third point: output the name of both horse objects from the array. So we're just going to be running a simple for loop with a range, or I could do this for horse in horses, since horses only stores two horse objects. I'm gonna be printing the name, so it's gonna go like, oh yeah, so what we need to do over here is we need to use the get name function over here, because that's why we have 5 marks. The examiner is testing you to see how much you know about your own class. So we know that we have to find the getter named get name over here, so we're going to be using this. Now horse dot get name, and with that I think we're gonna get our answer. Yeah, see, it works perfectly fine, and this was the way that we need to attempt part B, part 1, and yeah, we've gotten 5 marks over here. Oh, one more thing, it's good to declare it using comments. So declare horses alright, so we declared the array with space for 2 horse objects, then we stored the 2 horses, then we output the names of both horse objects from the array. Now moving on to part C. The class fence stores data about the fences. Each fence has a height in centimeter and a risk number. Each risk is a whole number between 1 and 5. A risk of 1 means the fence is the easiest to jump. A risk of 5 means the fence is the hardest to jump. Alright. So this is the class diagram for fence. Now we need to make another class for fence. So we're gonna be doing the same way. There is no mention of inheritance over here, so I'm not gonna be doing that, I guess. Yeah, I guess I'm not gonna be doing that. So we're once again gonna be defining the constructor is gonna be taking height and risk. So I'm just gonna be naming this p height and p risk. Gonna be declaring the attributes. So this is an integer obviously, and this is also going to be an integer, and with that I think our job is done. Alright. Oh, and the get method as well, so we need to make the get method as well. So def get height we're going to be returning self height, and in def get risk we're going to be returning the risk. Yeah, so yeah. Alright, now moving on to part 2, the array course. So there's another array named course, stores 4 fence objects. Alright, the user inputs the height and risk for each fence, and these are validated before each fence is created. Amend the main program, so we're moving out of the class fence. We're going to be declaring the local array course, take as input the data for 4 fences from the user, loop the input until both the height and risk are valid. Alright, so we need to apply a validation check over here, most likely a range check, because it's already given us that risk is 1 to 5 and height is 70 to 80 inclusive. And then create an instance of fence for each of the 4 valid fences and store each instance in the array, being awarded 5 marks. Alright, so let's do this. So we're going to be declaring course, and since it's going to be storing 4 fence objects, I'm just going to be following the same method. So the fence constructor has only 2 values, so I'm just going to be initializing these to -1, -1. for x in range 4, because we have 4 values. Now we need to take as input the data for 4 fences from the user. So we're going to be running a for loop. So first we're going to be asking for the height, and we're going to be converting this into an integer. So we're going to type in enter height between 70 cm and 180 cm, 180 cm inclusive. Alright, so we need to validate this now. So while height is less than 70 or height is greater than 180, this is gonna keep on running as it's invalid. So I'm just gonna be printing incorrect height and re-enter. Yeah, you know, like it just looks better that way. So once the height is validated, we're going to be moving on to the risk. So risk is equals to, once again, integer, and import enter risk number between 1 and 5 inclusive, and we're gonna be validating this like we did with the height. So while risk is less than 1 or risk is greater than 5, we're gonna be printing incorrect risk number and copy pasting this. Yeah, so this way I think we are done with the validation. Alright, and then what we're gonna do is store make an instance and then store it in the course with the corresponding index number. So once we validate the information, we're gonna be storing this inside the course array. X is gonna be the index, and then we're gonna be making an object of height and risk. Yeah, see, so here we've created an instance of the fence class, and here we've stored it inside the corresponding index. So once the whole loop refreshes, every value refreshes, and it's already going to be stored inside course. So yeah, I think it works. We declared the local array course. We took as input the data for 4 fences, and we loop the input until both height and risk are valid for each fence. So we've clearly done that, and we've created an instance for each of the 4 valid fences and store each instance in the array. So looks good. Moving on to part D. The chance of a horse jumping a fence without knocking it down is calculated as follows. If the height of the fence is more than the maximum height a horse can jump. So alright, the success percentage is 20% of the horse's percentage success. The risk does not affect this value. If the height of the fence is less than or equal to the maximum height a horse can jump, the risk gives a modifier value to multiply with the horse's percentage success. Alright, so this is a table that they've given, and we need to make the method success in the horse class. So here this is the horse class that we made in the beginning, and here they're telling us to create the method success. Now let's read what they have to say about success. So success takes the height and risk of a fence as parameters, calculates the percentage chance of success for that horse jumping the fence without knocking it down, turns the calculated percentage chance of success as a real number. Okay, so to calculate the percentage chance of success, we're gonna have to read the whole question. So this is the percentage chance of a success. If the height of the fence is more than the maximum height a horse can jump, max fence height. So if we move on to the class diagram of the horse, we can see that max fence height is the maximum height that the horse can jump. Alright, so this is the maximum height that a horse can jump, and in the fence class diagram we can see that height is the height of the fence, obviously. So what they're trying to say over here is that if max fence height is greater than if the height of the fence is more than the max fence height, the success percentage is 20% of the horse's percentage success. Alright, and percentage success is a parameter value that we've been given to initialize the horse instance. So here we can see that this is the third parameter over here, percentage success. And if the height of the fence is greater than max fence height, meaning that if the height of the fence is greater than the maximum height a horse can jump, then the success percentage is 20% of the horse's percentage success. So this is basically this is just gonna be reduced to 20% of what it actually is. And if the height of the fence is less than or equal to the maximum height a horse can jump, the risk gives a modifier value to multiply with the horse's percentage success. Alright, so we're just going to be dealing with the third parameter that we've been given over here, and the risk value is basically the second parameter that's been passed into the fence class. Alright, so we've been given an example over here. The horse jet has percentage success of 65 and max fence height of 160. So this is the horse class that we've been shown as an example, and the fence object has a height of 140 and a risk of 3. Alright, so the height of the fence is less than the horse's max fence height in this example, yes, because 140 is less than 160. Therefore the risk is used, meaning that this value is used. So the risk of 3 gives the modifier 0.8 according to this table over here, and the modifier 0.8 multiplied by percentage success, which was passed as a parameter over here, and this gives the value, the chance of the exactly. So this we're just going to be returning this value over here. Alright, so you can see that once we ran through the question carefully, we understood what we were being asked and what we are given and what we have to deal with. So let's get started with success. So we're going to be taking the height and risk of fence as parameters. So I'm just going to be naming this fence height and fence risk, because this is just going to get even confusing. And we're going to be calculating the percentage chance of success for that horse jumping the fence without knocking it down. So we're going to be moving to the starting part of this question, and if the height of the fence is more than the maximum height a horse can jump, meaning that if fence height is greater than self dot max fence height, then what we're going to be doing is returning percentage and it's going to be multiplied by 0.2 as it's reduced to 20% of its original value. Alright, and if this is not the case, then what we're going to be doing is that we're going to be using the table values over here. So if risk is equal to 5, then return self dot by 0.6. If then return percentage success by 0.7. By 0.7. Oh wait, remember to use elif conditions after you've used one if condition. This is basically the hierarchy of the conditional statements in Python. So elif risk I'm just going to be copy pasting this. And I'm just going to be returning this as it is, or I'll multiply by 1.0. It doesn't really matter. It's just going to be the same value as it was previously. So yeah, I think this is the way to go. So the reason why I've used return after every condition is that it immediately breaks out of this method. Otherwise it's just gonna create unnecessary changes and mess up the program. Alright, so I think this works pretty fine. So what I've done over here is that I have completely followed the question. If the height of the fence is more than the maximum height a horse can jump, meaning the self.max fence height, as it was mentioned previously, then it means that the success is 20% of the horse's percentage success, meaning that it's going to be multiplied by 0.2, and the risk does not affect this value, meaning that we have completely ignored the risk in this case. Else if that was not the case, then we're going to be using table values, and here we have used the table values. So if it was 5, it's going to multiply by 0.6, for 4 0.7, for 3 0.8, for 2 0.9, for 1 1. Alright, so I think that works. We've been awarded 5 marks for this, and what we've done here is take the height and risk of a fence as parameters, calculate the percentage chance of, we've calculated that, and then we've returned it as a real number. Alright, now moving on to part E. Write program code to amend the main program to calculate and output the chance of the first horse jumping each of the 4 fences without knocking each fence down. Calculate and output the chance of the second horse jumping each of the 4 fences without knocking each fence down. And we have to copy the output style as the examiner has shown us. Alright, so let's go ahead with this. For this we're going to be having to use the success method of the class horse. Alright, so since we made two arrays over here, the first array was our horses array and the second is our course array. The horses store 2 horses and the course stores 4 fences. And what the question is telling us that each horse has to go through these 4 fences, and for each fence we have to calculate the percentage success they have. Alright, so it's like each horse is going to be going through 4 fences, and for each fence that they cross through we are going to have to calculate the percentage chance of success they have for jumping over that fence. Alright, so this is gonna be running like that, and we're gonna be running this loop for a total of 8 times. So we're gonna be having 2 loops over here, and the first is gonna be obviously for the horses. Alright, so I can just define it like this: for horse in horses, which is 2, and then for fence in courses, in course. Yeah, so for fence and course, and these variables or these names that are defined over here, you can name them anything you want, but for readability I'll just define them as they are mentioned throughout the whole program, so it really doesn't matter what you name them, but this is just for convenience. Now we're going to be following this output style and calculating the percentage success. So keep in mind that whatever we've created, we're gonna be having to use that. So here I could have just typed in manually Beauty or Jet, which were the names of the horses, but I have to use the methods that I've already described in my class. So for that I'm going to be accessing the get name. Alright, for horse, if you recall, we had created the get name, and this is going to be returning the name of the horse. Alright, and then with a comma we're going to be containing the string, and fence. So for fence, what I can do is I could just type in X and convert this into a range for loop. And the reason for doing this is because I need to keep track of what fence I'm on, and for that I need an index. So that's why I can't operate this code without using an index, so I need this. And I could have also done the same for this, but it really doesn't matter, but for this it does because I need the index. I could have also just created a separate variable and incremented that, but since it already happens here automatically, I've chosen to do this. Alright, now at fence X, this is going to be storing on which fence we are actually on, and then we're going to be continuing the string has And here's the tricky part. Now we're going to be accessing the percentage success, and that lies in the horse function, in the horse class. So we're going to be accessing the horse, and we're going to be using the get success one. And if you recall, what success does, it takes the height and risk of a fence as parameters. Now how do we do that over here? We're going to be using the get height and get risk methods that we described in the class fence. Alright, so these are going to be the parameters of this horse method. So it's going to be course dot get height, and then course dot get risk. Remember to add the brackets, or it just returns the memory location. Yeah, so get height, get risk, make sure the names are exactly the same. And as this is going to be returning the integer, so I'm just going to be assigning a percentage chance of success. Right, so hopefully that works. Now, so what we did is we went over each horse, and each horse goes through every obstacle, and we've printed it in the same manner the examiner has told us to. So I think we're clear over here. Alright, so there are some changes that I've made to the code. So what's been done is that I've changed this into length, because range wants a number, not a whole array. So this has been changed to len. And previously I had made an error that I was using risk over here, but this was defined as fence risk, so I've just changed this into risk. It's shorter and easier to handle, so that's why. And here I hadn't taken the index, but instead I had taken the whole list, so obviously that was going to be incorrect, and same goes for here. And there were some bracket issues over here, so I fixed that up as well. Now one thing is that since we've used an index, meaning the range loop, so the same thing should also be applied for the horse loop, because what part 2 tells us is that calculate and output the average chance of success for each horse jumping over all 4 fences without knocking each fence down. So basically what we need to do is, this was the percentage success over here. Now we need to store these values for each of the fence that we move on. So what I plan to do is that I'm gonna be making an array of points, and it's just gonna be storing a null value with 2 rows, one for the first horse, one for the second horse. And what this is gonna be doing is that it's just gonna be storing the sum of all the 4 courses each horse has went through, so meaning this percentage success value over here. And what I'm gonna do is I'm gonna be changing this. Yeah, so I'll just leave that as it is. I'm gonna be changing this into range. Put your way up. Moti. So I pin in array points, and initialize it with a -1 with uh, two rows. And yeah, so what's gonna happen now is that I'm gonna be adding up the points for each horse. So points with the index horse is gonna be storing, it's just gonna be incremented with all of this over here. So for the first horse, when it's gonna be going through each of the fences, this value is also gonna be incremented. So in this way we have a hold of the total number of percentage success for each horse. But this doesn't store the average, and we want the average that's being demanded in part 2 over here. So for that, what we're gonna do is we're gonna be first storing average 1. Average 1 is gonna be the points in the index 0, and this is gonna be divided by 4. Average 2 is gonna be points 1 divided by 4, and if average 1 is greater than average 2, then print wait. So even if there is a difference, we're still going to be outputting the average chance of each horse. So we're going to be following the same format the examiner has shown us over here. So yeah, what I have done now is, it's a really unorthodox way of storing the points, but I've just replaced the value that was stored in each index with the average now. Alright, because initially it was storing the sum of all the points, but now it's going to be storing the average. So this is what I've done, and I have another loop, and now this final, if the final conditional statement is for the outputting of the name of the horse that has the highest average chance of success. So if the first was greater than the second, then it's just going to be printing horses 0 dot get name elif else Now you might be wondering, what if it's a draw? Well, in this case it isn't, because the examiner has defined it as that there will be no draw. Each average will be different. So now let's run this code with the test values that we have in part 3. So for this 152, 5, 21, 1, 130, 3, 145, 4. Oh, oops. This is in line 56. So the horse get name. Oh, so since this is an index, the horse is going to be acting like an index. Same goes for here. Hopefully it works now. 152, 5, 121, 1, 130, 3, 145, 4. Oh. Once again the same mistake. Alright, so here we have our answer, and looks like it works perfectly fine. So the horse Beauty runs through the 4 fences, has a different percentage success for each fence. Horse Jet runs through each of the 4 fences. Right, then we have calculated the average over here, and then we have the average of the other horse, and since Jet has a higher average, Jet wins. Alright, yeah. Alright, this was it for this question. We have completed the whole of question number 2, and I've gone through object-oriented programming really carefully. So this was a pretty long video. Hope you guys enjoyed. Hope you guys understood the concepts, and sorry for the mistakes I made here and there, but we have gotten over those as well. Alright, so yeah, this was it for this video, and I'll be seeing you in the next one.